talks about WebAssembly, if you can hear anything. It's sandboxed. It's platform agnostic, which sounds, these get more and more geeky as we go down here. So basically, it's not tied to a particular platform, and I'll show you an example on the next slide. But it's not tied to a CPU architecture. It's not tied to a particular device platform. It's completely agnostic. It's deterministic across architectures, which is basically like you can write this WebAssembly, and then no matter where it's running, it's going to run exactly the same. So we don't have this problem of like, hey, on ARM CPUs, it's going to do this with like numbers, or on Intel, it's going to be, it's all exactly the same. So given a particular WebAssembly module, it's going to be, you can be confident. And finally, the most geeky point here is that it's a backwards compatible W3C spec, which is the advantage here is that you write a WebAssembly module, it'll still run in 10 years. It'll still run in 20 years. That same WebAssembly module, it's not going to have, it's not going to break. So I think that's actually a really powerful thing that I've been thinking about a lot, is that, you can sort of create this like ideal module for whatever problem you're solving, and then you don't have to go, oh no, there's a breaking change that we have to, that we're forced to upgrade to. So WebAssembly works on every major platform, so browsers, servers, the edge, native, so that's desktop and mobile, and whatever might come in the future. So that, of course, AI glasses. So what exactly is WebAssembly? I'm not going to go into too much detail here, but here's my mental model of it. So in WebAssembly, everything is a number, and it's either an integer or a float, 32 or 64-bit numbers. And you also have access to an array of memory, which can, so it's like a big array of integers or floats. Everything's mutable, so that's sort of like an interesting contrast to Elixir. Everything sort of in Elixir is immutable by default, where it's sort of in this opposite world, which is modeled on how CPUs and memories work on computers. But there's no strings or data structures, there's no fetch, it's pretty low level. Like, so we're, not even having a string or an array or anything like that feels pretty constrained. And so if you have these WebAssembly modules, you can think of them as sort of like a little black box. And then you can import from the outside world. You can import numbers, memory, functions that you can call back. And then you can export those things too. So again, this is like my mental model of thinking about how might I use WebAssembly. Might be a really small piece of my application that just does one particular job. I might have multiple of these WebAssembly modules all running and maybe connected together. So I set out to create a library to help write WebAssembly. That's orb. And I wanted it to feel a bit like Elixir or Ruby, and you'll see that in some of the syntax. It is pretty low level, so it's built from the ground up for WebAssembly. So unlike other languages like Rust or Zig, which have amazing Zig compilation, amazing WASM compilation, this thing's really designed for what the feature set of WebAssembly is. So there's some sort of unique things that we can do there. It's not tied to a particular runtime, so there's things like WASM bindgen and stuff for Rust, and they spit out a WebAssembly module, but they also spit out like boilerplate for integrating into your browser or Node.js or wherever you're running. So it's like spits out this boilerplate code that sort of does the conversion to the outside world to WebAssembly world. So I didn't want that. I want this stuff. You saw the previous slide, cloud, mobile, whatever. Like, I want you to be able to write these modules and then plug them in wherever. So it's sort of this idea of write once, run everywhere. There's always a bit of probably have a bit of skepticism when you hear that, but I think there is something compelling there. It's built around this idea of composable modules, which we have in Elixir, of course. I want the output to be pretty small. I'm not doing computer science, levels of optimization here, but these things can be like in the order of just a few kilobytes. And I'm going to show at the end that you can compile this stuff on the fly, which I think is actually a really interesting thing I haven't seen before. So here it is. So here's the syntax. You can see you've got this cool go-to primitive. I think it's a pretty cool idea. Yeah, you can see that the syntax highlighting is pretty amazing. So yeah, it's there we go. No, of course, I'm joking. Here it is. So you define a module within range. So it's just an Elixir module. We just use orb. And then we write functions like we're writing Elixir functions. So def w, so w for WASM. And so here's a function that accepts a number, and then it's going to check whether it's within the range of 1 to 255. And so you can see here we get some pretty natural feeling syntax that's obviously feels like Elixir, but you notice some things like the sort of types that are there. So WebAssembly needs to know, hey, this thing's a 32-bit integer, so we have to tell it that. So this thing's like a work in progress. So like, if you have any opinions about any of this stuff, I'm really interested to see Jose's talk on types. I'm fascinated with what NX has done, and so this thing could evolve. So if you have any opinions here, yeah, please let me know. And then we have state. So in WebAssembly, these things are called globals. So I'm just exposing these sort of concepts straight through. I'm not really. This is where it's like built for WebAssembly. So we've got this 2 globals here, count and a tally. They're 32-bit integers. And then we can stick some numbers in, 1, 2, 3, 4. And then we're going to count out how many numbers you've inserted. And then we're going to have a tally of numbers that you have. So then when we calculate the mean, the average, we divide the tally by the count. So you can see it kind of looks like Ruby, which is interesting. But yeah, so we have these globals, and then we can write to these globals. And so my mental model of these is sort of like little classes almost, and so they can have internal state. And these globals are sort of like instance variables. And these insert and calculate mean, they're sort of like methods in a lot of ways. So to run this, I've created a little WASM time runner. So you just pass in the module, and then you can call. So we're inserting 4, 5, and 6, and then we calculate the mean. So the average of that is 5. And so yeah, this is sort of gives you some. You basically just sort of spin this thing up, and then call some functions on it, and then throw it away. But there's also a library out there by Philip Tessenow called WASMX. So if you want something a bit more gen server-y, a bit more robust, please check that out. So I'm going to just walk through some of the syntax here. So here's a thing that takes a int and like converts it to hex. So like 15 comes in, I think F would come out. So we've got control flow, so we've got loops, and again, I'm interested in what people think, because obviously I love Elixir's way of doing things with the for comprehension and stuff. But I'm sort of mapping directly one-to-one what WebAssembly has here. So I've sort of defaulted to what it has there. And the WebAssembly text format lets you name loops, because you can have multiple of them. So here we've got a loop called digits. We're going to loop through every digit. And then we're going to say like, hey, continue this loop if I is greater, if I is still above 0. And then we want to work with memory, so I've created this little thing using the access protocol. So writing to this offset, and you can see that we get all this like nice Elixir stuff, like $A to look up the int value for that particular ASCII character. So yeah, starting to see like how we can use the really nice stuff that's in Elixir. We can make use of it. And so that right pointer. It knew what type it was because they've got this unsafe pointer. It's like an unsafe pointer to a bunch of bytes. So that's what lets you use that access there, the @bang. So under the hood, everything's just like an int. I said everything's just a number. So under the hood, this right pointer is actually just an int. But we can make it a little bit nicer and unlock some like extra convenience stuff on top. So here's an example. So it's the exact same 926-byte WebAssembly module. And here's the thing running in LiveView. Hopefully this all works. So you can see here, it takes two inputs, so method and a path, and it's going to tell me if it's like 404, 200, and like some sort of HTML response. And so you can see here as I type different stuff, it's going to tell me like, oh yeah, there's a home page or there's not. So that's with LiveView, and it sort of depends on your latency here. I'm probably not going to turn on this emulator, but here's the same thing running in the browser. So this is where I think it could be interesting. Like I love LiveView, but there's certain scenarios I think where you want the lowest latency possible. So being able to sort of write this code in Elixir, but have it sort of jump across to the browser, I think is really interesting. So this stuff's just running in JavaScript land, and this stuff's running in LiveView land. So if you want to check that out, that's at that link. So how did this work? So I've made some convenient stuff. So here we've got a sort of like match thing modeled after the Rust match, but it's pretty simple. So yeah, we're saying like, hey, if the path that came in is slash, then it's 200, slash about 200, everything else is 404. So again, if you've got any opinions on any of the syntax, let me know. The strings are using like the sigil because I don't want to do any string interpolation, so we'd have to do that in WebAssembly, so I'm sort of really locking things down a bit. So these things nest, and so here you can see that we've got this function, getStatus, and we're first matching on the method, and then we're matching on the path, and the 405 status code, if you tested me, that's the method not allowed. I'd never remember that, but that's what that is. So here's another demo. So I'll just switch back. So again, I made this probably like a year or two ago. It's a lab converter. So lab is like if you've ever used Photoshop, it's like a cool color space that's like modeled after our eyes. And so here's it, this is in production. And so you can see here I'm sliding this stuff and it's calculating, hey, this is like the L value here, here's the A value. And I can change this and it's calculating the RGB, like converting it for me. And go away. And so, yeah, you can see it's like, works really well, but there's like a little bit of latency lag here. And, I'm definitely not saying, like, I think this is a great default, but I think there's just, for certain things that are interactive like that, you're probably going to have to like escape to JavaScript or something like that too. And now, you're sort of like writing a different language. So here's the same thing in WebAssembly. And so here you can see I'm dragging the stuff, and it's like really, really fast. So it's written using orb, and then the code is running in the browser. And so you can see that the WebAssembly module size is, about 4K, so it's pretty lightweight. So what's being done here? So the color maths is in WebAssembly, so converting from lab to sRGB, and then the SVG and HTML rendering are also in WebAssembly. And it runs both on the server and browser, so we actually have the initial HTML coming in to do the, so actually I'll show you that on the next slide. And then JavaScript forwards events to the WebAssembly instance, so I'll show that as well. So here's the code as it exists to like create this SVG and HTML. So you have this like build macro, and then you like have these strings, and then you can see like the swatch size is like it's like a float there, so that gets like interpolated in, and it all gets built together, like all gets squished into one string, and then the that's rendering. So, and you can see here that I've added a like little convenience thing that, hey, if we're rendering the L component, then we're going to render a slightly different output here. So if's just a macro in Elixir, so I can do stuff like this, and it feels, I've done a bit of Swift UI, and so sort of bringing some of those ideas across to here. So here's how you might, that module, that was the code there for defining the module. Here's how you might use it. And so here we call the toHTML like function on that instance. And then we get that initial HTML and we pass that to the template. So initial HTML there. And so you see on the other side here, we've got a little custom element that accepts that initial HTML. You can see the raw there on like the third line. And I've got some like JavaScript conveniences to sort of say like, hey, give me something like duck type that's going to have this toHTML function on it, and I'll render it for you and do the event listener stuff. So you can see here, just extracted some code. There's an update here. It's going to read toHTML from the WebAssembly module, just overwrite the inner HTML of the component, which is kind of crazy. So you saw that like that thing was actually pretty fast, and I'm doing like the most naive thing possible. So like every time I'm moving the mouse, it's actually replacing the entire HTML, and it actually seems fast enough. I tested on a little Android phone that I've got as a test device, and it was also very quick. And then we just use like this declarative sort of thing of with all the event listeners. So I haven't got this all fully fleshed out yet, but basically if you like, depending on the function that you export from your WebAssembly module, we'll be able to detect what event listeners that you want, and then like set all that boilerplate up for you and like forward those events on. So you can see that when we click, it's going to call the exported action, and then we update, which is just like renders all the HTML again. So what we often want to do is reuse code. And so here's a, like we might want to allocate some memory. So use orb, and then we've got two globals, a bump offset, and something else that we need to use. And so then we say, hey, we want like 1 page of memory. So WebAssembly, you have like 64 kilobyte pages of memory that you that you sort of ask for one by one. So here we're saying we just want 1 page of memory because we want to do some stuff with memory, and then we're going to we want to like allocate this memory. So bump allocate is just this thing that just like increments some whatever number of bytes you wanted. So that like this seems like a useful thing to have and reuse. And so here I can have my other module that's going to reuse that thing. And so I say bump allocator.include. It's going to like copy and paste those functions in for me. And then you can see with this example here, I'm going to then use that bump alloc to allocate that thing of that size. But we can go one step further. So we can wrap that up in like a using, and then just go use bump allocator. And like it's just all that other stuff that it needed, that memory, the memory pages and stuff. We can just like encapsulate all that stuff in there. So we just sort of say, use bump allocator, and just now we can start doing stuff. Feels very natural and lightweight. So we can have a bunch of these different modules and then like compose them all together, reuse them, and even better, we can publish them to hex. So this is just like Elixir code. So if I want to go like URL encoded or whatever thing it is, HTML rendering, I can just publish that to Hex, which is an amazing package manager. So part of what I was thinking with this project was like, I guess the alternative route was like create some custom programming language, and then it's like, oh god, I have to like create the syntax highlighting like for GitHub, and then like, you know, VS Code and a language server and a package manager and blah 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 blah. Like that's a lot of work, and I'm probably going to create like really bad versions of those things. So why not like get the best in breed and just publish it to Hex. So that leads to this thing that I'm also working on. So Orb's going to be like low level, expose some like functionality, like just the sort of the bare bones. But this stuff is composable. So I've got this idea of like a standard library for that you might want to use for common things. So bump allocator, formatting numbers, string building, URL encoding, string utilities, maybe iterables. So if we could have this library and becomes like a little bit of a standard lib that you just sort of use on a lot of projects, it's not going to feel as low level now. So that's part of what I'm hoping to do with orb. It's gonna, it's not gonna feel like just writing Elixir, but I want it sort of be this middle ground. And the spider is this is a silver orb spider. It's a species that lives in Australia, and so that's where the name came from. So WebAssembly, spiders assemble webs, silver orb. Yeah, that's if you're wondering what the name meant. And so you saw that slide before where we were saying like use bump allocator. So now we can just go like silver orb, bump allocator, string builder, URL encoded, and so forth. So you can just like pull that library down and just use them in your project. So just see how I'm going for time. So here's some other ideas. And so this is like the power of what Elixir gives us, is that we can write some really cool macros. So here's an idea which I've sort of tried in different forms, and I ported it to orb, of a like state machine. And so we've got 4 states here: idle, loading, loaded, failed. And then you can read that state with the getCurrent function. And then we have this on macro, which declaratively says like, hey, when the load event comes in and we're currently in idle, then we're going to transition to loading. If we succeed, then we're going to transition to loaded and failed and so forth. So this stuff feels really nice and natural. And so this is where you might not actually use orb itself. It might be sort of like you might use a higher level layer like this, and it could make it even nicer. That export enum might be just sort of like, hey, what are the states? Why I think this is compelling is that you can write this, define the state machine, and then like run it anywhere. So you can run it on the server, run it in the browser, run it on mobile. Like define, write it. Sorry not to use those words, but yeah, write it once, run it everywhere. Like we're not writing entire apps here. We're writing like little modules that might do state machines, parsing, displaying output, like rendering HTML, and then like being able to like ship that to all these different things and have it just work, I think would be really compelling. And then finally, sorry if I feel like it's very hard to tell how quickly this stuff is going, but try and slow down here. So finally, this is this idea of dynamically compiling on the fly. So if you've ever used Zig, it's got some really cool comp time and inline features. And if you've ever used like C, you have this like things like the pre-assembler or whatever. It's like pretty crude stuff. But we have the full power of Elixir here. So I'm saying, hey, I've got this orb function that's going to tell me whether this particular author can edit this thing. And so I'm going to say inline, and now we're in Elixir mode. And so I'm going to say, like, hey, give me the current user, and then we're going to match on that. So if we're a viewer, I'm going to then switch back to WebAssembly code here and say, like, hey, the logic is if the author is the user, then they can edit their own posts. And then you can see at the bottom there, type admin. So admins can do everything. And so I just say 1, which is basically just saying true. I haven't decided yet whether to make true into just 1, but everything's an integer. So yeah, we just return 1, which is basically just saying yes all the time you can edit if you're an admin. And so this is this idea is that you get access to the entire Elixir ecosystem at compile time. You saw Hex and so forth, and you get the WebAssembly ecosystem at runtime. And so the Elixir ecosystem, we've got access to modules. You can do all sorts of interesting stuff as you're compiling those modules. Hex, got the amazing community. We've got macros. So you saw some of the stuff with the state machine stuff, but there's like a whole ton of ideas I have of making like high-level DSLs to make this stuff like really nice to use. And then like WebAssembly, it's portable, fast, safe, predictable. So there's this really interesting marriage here, I think. So yeah. So this thing's available on GitHub, of course, royal-icing/orb. And then if you want to follow the project, I've decided social media is probably just the easiest. So Royal Icing everywhere. That's on Twitter, Mastodon, and Blue Sky. And thank you very much.